So a ball is dropped from rest and falls 15 meters. How much time does it take to fall this distance? And as always, we're going to ignore air resistance. So this is a free fall problem. And just like I usually do, I'll try and diagram the actual motion that's happening. And then I want to list out all the details that the question gives us. For example, I know that we are dropping a ball from rest, so I know my initial velocity, and I know that it's going to fall 15 meters, so I know my change in position. We are looking for the amount of time it takes, and even though it doesn't explicitly say so, we also know one more detail about the motion of this object. Because this is an object that is free fall, we know that the acceleration of this object is going to be negative 10 meters per second, right? Or it's going to change its velocity in the negative direction by 10 meters per second every single second. Okay? So that with all of these free fall problems, we can always assume our acceleration. Okay, in this class, it's going to be negative 10 meters per second if you're going down. Right. Okay, so now we have to pick from our list of possible equations that can help us solve for time. Okay, for example, we could potentially use this one because the only thing that we're missing is time for that one. We could use, so we can't use this one because we don't have the final velocity. Same goes with this, right? And this one as well, and that one too. Okay, so the only equation that we have left to use is this guy right here. For example, we know the change in position, 15 meters. We know the initial velocity, 0. We know the acceleration, which is negative 10. So all we're solving for is that single variable, solving for time. Okay? Well, you'll notice that if we start plugging in values, okay, so my change of position was 15 meters. That's going to equal my initial velocity multiplied by time, so 0 meters per second times time. I'll just throw some parentheses here to keep it simple. And then I'm going to add that to 1/2 of our acceleration, which we said was negative 10, okay, meters per second squared. And then we're going to multiply this whole thing by time squared, okay, which we don't quite have yet. So when solving these equations, we can eliminate this whole chunk right here, right? 0 multiplied by anything is 0, so we don't even have to worry about it. And then we just have 1/2 multiplied by negative 10, okay? So to clear up our equation, 1/2 multiplied by 10, so that would be negative 5, and then that's going to be multiplied by time squared, right? And then we want to divide both sides by negative 5. I guess technically our change of position would be in negative 15, right, if we're going in the negative direction. So I'll just throw that up there as well. So negative 15 over 5, that gives us positive 3, and that's equal to time squared. Okay, so now all we have to do is take the square root of both sides, and the square root of 3, of course I don't have that memorized, square root of 3 gives us 1.73, okay? 1.73, and that is our time, so that's going to be in seconds.